Next we move to probability of compound events. Compound meaning more than one typically. Two events are going to be what we call independent if the second event's not affected by the first. If they're dependent events, then the second event will be affected by the first results. So if we have two events A and B that are independent and we want to find the probability of A and B occurring, we multiply those two probabilities together. If we have dependent events, so one depends on the other, all right, then what we're going to do is find the probability of A and multiply that by the probability of B once A has occurred. And that's also written in this form right here, probability of A times the probability of B slash A. That means once A has already occurred. So let's take and look at an example. So we've got in a survey 7 out of 10 shoppers do not use coupons and 3 out of 8 only buy items on sale. We want to find if using coupons and only buying on sale are independent events, so one does not affect another. Find the probability that shopper uses coupons and only buys items on sale. So we've got to determine what our two events are. One is that the shopper uses coupons, and two is that the shopper only buys items on sale. So we're going to look for those specific probabilities and then multiply them together. Now you'll see our first bit of data talks about 7 out of 10 shoppers do not use coupons. Well, from that we can gain information on the shoppers that do use coupons. So if 7 out of 10 don't use coupons, 3 out of 10 do use coupons. So that's their probability. So that's like PA. And then we're going to multiply that by the probability of event B happening. And event B is that they only buy items on sale. Well, here's our event B. 3 out of 8 buy items on sale. So I take 3 out of 8, multiply those two together, and we get 9 out of 80. And that's our probability. So in this next problem, we have a person with a bag of marbles, 4 red, 6 green, and 3 white. You pick 3 items from the bag. We want to find the probability that all those 3 items are green marbles. So basically, this is a combination type problem because it doesn't really matter what order you pick things in. You're just reaching in and picking out 3 things that are going to all be green in this case. So doing that like a combination style problem, we have to ensure that all of our marbles are green. So we only want to pick from our green subset. So we have 6, choose 3, over, we have a total of 13 marbles, and to find out how many ways we can pick 3 of them, that's just 13, choose 3, and there's your probability. Now we talk about a specific type of probability with mutually exclusive events, and in this case, when 2 items are mutually exclusive, it's impossible for them to happen together. So the probability of A and B occurring at the same time are nil, 0. So the probability of A or the probability of B happening is the sum of those two probabilities. So again, we've talked about 2 things right now. We've talked about compound events that deal with the word and between them, very similar to this, and this idea of mutually exclusive that uses the word or. Or is going to indicate that you're going to be adding things, and is going to indicate that you're going to be multiplying probabilities together. So those are some indicators. If we talk about inclusive events and the probability of A or B happening, again, the or indicates there's going to be some kind of adding going on between the 2 probabilities. But if we talk about inclusive events, we talk about an overlap occurring or something that can occur in both of the sets. So in that case, it's kind of like looking at our Venn diagrams, if you remember those. We could have 2 things occurring, but a group of things in both of those two sets. Well, if you included that number that was in the two sets twice, you would have more items than actually exist in your picture. So if we have inclusive events, once again, and we want to find the probability of one event or another event happening, we add those two probabilities and subtract off the overlap. So let's do a couple examples that use this principle. So we've got Joe with 6 nickels, 4 pennies, 3 dimes in his pocket. He takes one coin out, and we want to find the probability of a penny or a nickel. So this tells us we're going to be taking and adding these two probabilities together, because if we're only pulling one coin out, the coin can't be a penny and a nickel at the same time. So these are exclusive events. So the probability of pulling a penny out, well, he's got a total of 13 coins, and of them 4 pennies. So that's the probability of a penny. And then, or we want the probability of a nickel. He's got 6 nickels over 13. Add those two up, we get 10 over 13, and there's our probability. In this example, from a standard deck of 52 cards, we're going to find the probability of pulling a face card or a red card. And from our previous lesson, we found that there were face cards that were also red cards. We have kings, queens, and jacks. And then we know that our red card possibilities are our hearts and our diamonds. So what we're going to do is we're going to first of all find the independent probability of a king, queen, and jack, then find the probability of a red card, and then we're going to subtract out those that are both. And we'll talk about that when we get to it. So the probability of pulling out a face card, we know there are 3 face cards and 4 different suits. So that gives us 12 out of 52 possibilities of drawing out a face card. Now we know that half of our cards are red, so that's 26 out of 52. And we add those together. So this is like the probability of A plus the probability of B. And now what we want to do is we want to subtract out the probability of A and B. So how many cards are both face cards and red cards? Well, half of these 12 are going to be face cards and red cards. So we pull back out 6 out of 52 cards to get our total probability. So in this case, we have 32 out of 52 being the probability, and obviously we can reduce that to 8/13. So in this next problem, it states that in a hospital group, some have high blood pressure, some have AS, and some have both. Probability of the high blood pressure is 3/8. Probability of high blood pressure and AS is 1/4. And the probability of high blood pressure or AS is 13 over 24. And we want to find the probability of just having AS. Well, I would do this problem using a little bit of algebra, because what we know is in this problem they're actually giving us probabilities rather than having us find them. And if we want to take and find the high blood pressure probability, add that to the AS probability, subtract off the high blood pressure and AS probability, we would get the high blood pressure or AS probability. So in this case, we know the high blood pressure is 3/8. We don't know the AS, that's what we're looking for. We know the overlap, the high blood pressure and the AS is 1/4. And we know the high blood pressure or AS is 13 over 24. So now we just solve for X. We have 13/24 minus 9/24 plus 6 24ths is going to equal x. That gives us a total of 10 24ths or 5 12ths. And in this next example, you've got 4 boys, 5 girls on a debate team, and a panel of 5 needs to be chosen for the next debate, and we want to find the probability of having at least 3 girls on the panel. This at least brings a different dimension into the problem. At least means we could have 3 girls or 4 girls or 5 girls, which means we're going to have to find all of these probabilities, and because of the word or, add them up. So again, this is like a grouping problem. We've got to ensure that we have 3 girls, so we must pick from the group of 5 girls to get our 3 girls. So that's 5 choose 3. But then we've got to include boys in this, so we include those 2 boys by taking from the boys group 2 boys. That's all over. We got 9 kids, and we're choosing 5. So we've just done our 3 girls. Now we're going to add to that 4 girls. So from the girls group, we pull 4. From the guys group, we pull 1. And then now we've got to do our 5 girls. Girls group, choose 5. There's no guys. And then we'd add all those up to get our combined probability. So make sure you fill out your My Math Lab, and we'll discuss this more tomorrow.